Hello everyone, and welcome to my video presentation. Today I will be talking about climate change in relation to the second law of thermodynamics. So without further ado, let's jump right in. The second law of thermodynamics speaks on the quality of energy. It states that as energy is transformed or transferred, more and more of it is wasted. It also states that there is a natural tendency of any isolated system to degenerate into a more disordered state. Therefore, for any spontaneous process, the entropy of the universe increases. A professor of physics at Missouri State University, Saibal Mitra, discussed this law by saying that there are a number of ways to state the second law. At a very microscopic level, it simply says that if you have a system that is isolated, any natural process in that system progresses in the direction of increasing disorder or entropy of the system. He explained that all processes result in an increase in entropy. Even when order is increased in a specific location or system, when you take the entire system, including the environment, into account, there's always going to be a net increase in entropy. For example, crystals can form from a salt solution as water is evaporated. Crystals are more orderly than salt molecules in a solution. However, vaporized water is much more disorderly than liquid water. The process taken as a whole shows a net increase in disorder. So this net increase of entropy I was just talking about directly relates to an increase of heat trapped in our atmosphere due to greenhouse gases. As the Earth receives energy from the sun, and anthropogenic activities produce their own greenhouse gases and entropy into the atmosphere, these products perpetuate climate change and global warming. These greenhouse gases, such as carbon dioxide, nitrous oxide, methane, and other synthetic chemicals, retain the heat in our atmosphere and disrupt the balance of the energy the Earth receives from the sun and the amount of energy the Earth is able to emit back into space. Through the combustion of fossil fuels, coal mining, natural gas production and distribution, various agricultural and industrial activities, etc., greenhouse gases are released into the atmosphere and make it impossible for the Earth to expel excess energy. This graph here shows a breakdown of the greenhouse gas emissions in 2018. And today, carbon dioxide is still reported by the Environmental Protection Agency to be the most important anthropogenic greenhouse gas because it accounts for the greatest proportion of the warming associated with human activities. In this article, Thermodynamics of Climate Change Generalized Sensitivities by V. Lucarina, K. Friedrich, F. Lunkheit, they focused their research on the linear relationship between temperature and the logarithm of carbon dioxide concentration, parts per million, in the atmosphere over the past 50 years. They were able to extract observational and numerical data from 37 different trial runs of a simulation climate system. Their mathematical findings led them to support the conclusion that as carbon dioxide concentration in our atmosphere increases, so does the global mean surface temperature of the Earth. They took a look at what they deemed to be the most important thermodynamic variables of the system, such as thermodynamic efficiency, the time average of the rate of material entropy production, the degree of irreversibility of the system, and many others. They also found that an increase in carbon dioxide concentration caused a steep decrease in the efficiency of the climate system, a decrease of about 35% to be precise. The actual average total rate of material entropy production increased as carbon dioxide concentration increased as well. Unsurprisingly, heat and energy production experienced an increase with an increased carbon dioxide presence. This increase of carbon dioxide also greatly affected the degree of irreversibility of the system. Irreversibility being that the system could not return to its original state pre the carbon dioxide influences. In conclusion, the resulting generalized sensitivities proposed in these trials demonstrate that the climate system becomes less efficient, more irreversible, and features higher entropy production as it becomes warmer due to carbon dioxide concentrations in the atmosphere. As more and more spontaneous processes happen on Earth, as the sun provides more energy in the form of solar radiation, and as greenhouse gases continue to pollute our atmosphere, it's clear to see how the second law of thermodynamics goes hand in hand with perpetuating climate change and global warming. In my final remarks, I would just like to remind the audience that it is so important for us to think about how our everyday lifestyles affect the world around us and how we should be more mindful of our carbon footprint. I cannot reiterate enough how critical this time of human history is in either setting up future generations for success or failure in life on our planet Earth. We may not have the ability to decrease the amount of solar radiation the Earth receives from the sun, but we do have the ability to reduce greenhouse gas emissions. These practices are not sustainable. We must change and do better as a society geared toward protecting our planet and the future generations. Thank you so much for listening and have a great day.